I'm an educator at MOHAI, and this is Idea Lab at Home. Join us as we tinker, experiment, and create our way through history with a new topic and activity every month. This month, we are exploring bridges, and to do that, we are going to start off outside. Seattle is a city of water and hills. They are all around us, and the different parts of our city are connected by nearly 150 bridges. Some of them are tall, some of them are small, some open and close, and some even float. Each of these bridges is unique depending on where, when, and why they were built. Let's take a look at some of the different bridges that are in and around Seattle. Right outside MOHAI, we have this bridge, which is a small truss bridge, which is a variation on a beam bridge. And the truss has strong shapes like triangles and an arch in it. And this one is only for pedestrians on foot, on wheel, and their dogs. There are no cars allowed on this bridge. The Fremont Bridge is a really great example of a drawbridge, which Seattle has many of. And the Fremont Bridge is a bascule bridge, meaning that it opens due to a counterweight at the bottom. And that one has separate lanes for cars and pedestrians. Seattle has two floating bridges, which are supported by the buoyancy of pontoons underneath the roadway. The Cohen Park Bridge is an arch bridge, and arches distribute compression through their entire form and transfer weight onto their abutments. We have to travel a little bit further to find an example of a suspension bridge. The Tacoma East 21st Street Bridge is an example of a cable-stayed bridge, meaning that the cables run directly from the roadway up to a single tower that bears the weight. This is unique from a regular suspension bridge, which Tacoma used to have an example of. And a regular suspension bridge, the roadway is hung from ropes, cables, or chains that are hung between two anchorages as opposed to one. Engineers also have to consider forces like torsion, which is the twisting or rotating due to high winds, shear, which is when the bridge is kind of pulled apart in opposite directions, resonance or vibrations, and also the weather whenever they're designing their bridges. Torsion and resonance are what caused the Tacoma Narrows Bridge to collapse in 1940. Da Vinci Inventions is the special exhibit currently on view at MOHAI. Created by Grande Experiences, the exhibit explores the work of Leonardo da Vinci as an artist, scientist, engineer, inventor, anatomist, and more. Leonardo da Vinci was fascinated by water and the way it moves, and he designed several inventions that help us move over, under, and through water. One such idea was for a portable bridge that is temporary and requires no fasteners. You can build a version of this bridge at home. Let's go inside to find out how. To do this activity, you are going to need a flat surface and 18 or more of either wooden paint stirrers, jumbo craft sticks, or pencils with rubber bands tied around each end. Now, there are a couple of different ways you can approach building your bridge. This is the way that I like to do it, which is building from the center outwards. And I like to use paint stirrers, so that's what I'm going to start with. And to start my center of my bridge, I'm going to take two paint stirrers and place them parallel and vertically in front of me, and then make a square by placing two more horizontally on top, and then one right in the middle, vertically on top. Then I'm going to get ready with two paint stirrers, and you can start with either side, whichever one you want, but you're going to carefully lift up your outer beam and slide a new horizontal beam under the outside one and over the middle one twice. And then you're going to get two more ready on the other side to go, and do it again. So lift up your outermost beam, slide a new one under and over your outer and middle beam, and then maybe adjust if you need to. And then you're going to do it again, alternating one side then the other. And you'll just build it out by sliding a new vertical beam underneath, and then having 2 ready to go. Pick up the outer one, slide a new one under and over, and repeat on the other side. So sliding one under, lifting it up, horizontal under and over, horizontal under and over. And you can repeat this as many times as you want. Whenever you're done, test out your bridge. How does it handle weight in different places? How does it handle weight if you use different kinds of materials? If you were to adjust the bridge design or build it slightly differently, could you make it sturdier? Could you make it taller? Could you make it longer? Play around with it, and happy exploring. You can locate the bridge instructions below or on our website at mohai.org/education. You can also check out the MOHAI Minute on Seattle bridges on our YouTube page, and also explore photos of historic Seattle bridges in our online collection at mohai.org/collections. Thanks for watching.